So welcome to episode number 17 after a hibernation period. We are back to do an update recording, which hopefully will be a benefit to the Albright community. So hello again, Josh.
Hi, Adam. Good to see you again.
Yes, absolutely. It's good to see you. We were discussing before I hit the record button that we should try to get together for lunch at some time. But I've seen Josh once face to face, and that was when I got a antigen test last fall. The health center is doing these antigen tests for people that showed up, and so I figured, just in case, I've been seeing students in the classroom. It's free. I might as well. I came back negative at that time. So yeah, I saw Josh there. That was more mask to mask than it was face to face. So
that's right. Yeah. We can hopefully we continue to move forward with real live in-person stuff.
Yeah, I tell you what, this has been such a weird piecemeal kind of process, this whole pandemic. I mean, just when you think it's, we're sort of like, beating it down and we're actually getting somewhere. And now we have, things like the Delta variant and all this other stuff popping up and vaccine hesitancy and all kinds of things. And so I guess we'll kind of touch on some of that today. So how are things going for you, Josh?
Good. Thanks. We're just gearing up. We have, since it's the beginning of August here, some students actually start to arrive on campus as early as the beginning of August. So we're starting to see students get back on campus, which of course is that was our success story last year, is having students on campus, and so here we are again. Just like you said, Adam, I was early in the summer looking at these numbers drop quickly and nicely, and I was unfortunately reminded of my feelings last year at this time when we started to surge again. So still hopeful, but we definitely, every time you think that there's going to be an end to this coming up, it seems to throw us another curve.
Yeah, and I really thought we were kind of over the hump, because I mean, throughout the pandemic, we seem to follow a trend where maybe 2 to 3 weeks after something happened in Europe, it kind of happened here. And there's that wave of Delta, big spike in Great Britain, and I forget exactly when that was. It might have been, I don't know, May or something. And I was like, okay, so we can get through May and into June. Based on it, the historical precedent, we might be okay. And we kind of were for a while. It wasn't really until the last maybe 2 to 3 weeks that, Delta's really reared its ugly head, and we'll get into all that, the nomenclature soon. But yeah, it stayed low even several weeks after the surge in Great Britain, and then for whatever reason, it took a little longer for it to really sort of take off in the United States. And now I think the latest estimate, it's almost 90% of all virus that is sequenced right now or analyzed is coming back as the Delta variant. So the SARS-CoV-2 original that started in sort of like January of what would have been 20, I suppose, or late 2019, that's been displaced. And then the Alpha variant, which I believe originated, or it was first seen at least in Great Britain, that kind of took over. And now that's been displaced in this country by the Delta variant, which was first seen in India. And so they've changed the nomenclature to be a little more sensitive, I think, to, I guess, like just, countries and, people around the world. And so, they're trying to get away, I think, from naming viruses and variants after a certain country of origin or a certain population. And so rather than call it, say, like the India strain or the Britain variant or whatever you want to say, they started using the Greek lettering system. So, alpha, beta, gamma, now we're delta, and we'll probably end up getting to epsilon and all the other ones. So
It's funny though, because they do tend to add that that first originated in comment after in the news articles, which is
in the news articles they do, yeah.
That we're trying to get away from that, but dragging us back in.
Yeah, right, exactly. But that's really common in, virology. I mean, that's been going on for, I think since the beginning of the field. I mean, like Zika virus was named after, I think, the Zika forest in Africa, the Rift Valley fever. I mean, they're just example after example. And I don't know if there's, if it's really going to be, sort of standardized across the board, but I think they're at least trying to get away from naming it after a place, at least for the SARS-CoV-2, because it's so, prevalent and in the news all over the place. So, yeah. And then on top of that, there's also viruses named for example, there's a virus called monkeypox, which is related to the virus I work on. And it actually circulates mainly in rodents in nature. At least it's thought to circulate in the reservoirs, actually rodents in nature, and it accidentally goes into monkeys sometimes. But it was first identified in a non-human primate. And so it was called monkeypox, and we're kind of stuck with it, even though it's not really circulating widely in monkeys. So there's all kinds of problems with nomenclature out there. So did you want to did you go on a vacation all this summer? Did you get to travel, get to relax?
I relaxed as much as I could. I have 4 kids, as I think we've talked about before, but so I have one that's going to be a senior this year in high school, and one that's going to be a junior in high school. And the one that's going to be a junior plays field hockey, so she's going through the recruiting process for field hockey. It happens early. My oldest, the senior, is a soccer player, so he wants to play in college, but that recruiting happens now through actually the beginning of summer after senior year. So we did a lot of looking at colleges, virtual tours,
Okay.
a couple drive-by tours.
Okay, cool.
I was checking to see if campuses were allowing visitors or not, and then sometimes just driving in and driving around.
Right.
I didn't get questioned anywhere to say.
Okay.
But we did wear our mask, because I didn't want somebody to have to say,
Sure.
"Come on, wear a mask for us," which we like to do at Albright. Wonder if our visitors can just throw a mask on for us.
Yeah. Oh, cool. Yeah, it's just weird. Yeah, weird time. I remember when I looked for colleges and stuff, it's very, very different than what they're having to do now. So, but at least
it is very different. And I have 3 older brothers, so when I was even younger than my youngest right now, I was dragged around to all the college tours, and so my wife thought it would be great for the whole family to go. And I said, I don't think everybody needs to go on all these, because so I did spare at least the younger 2 from some of the visits, but they did get to see some. I think it's a good experience for them. Yeah. But not something that we really wanted to spend all summer on, but we did.
Yeah, well, it is a big decision, right? So you want to make sure that you're seeing what's out there, making sure it's a good fit. So for sure. So can you go through for our listeners and viewers, what is the plan for Albright this fall? And, in terms of reentry and monitoring, like what's
Sure.
the plan for COVID?
Yeah, so so there was a large group that spent a good amount of time revising the CARE compact. So that has an outline for our students to talk about, the shared responsibilities that we all have, and what students agree to do our best to keep COVID under control. Part of that is our return to campus testing. As you're well aware, and probably a lot of our viewers are, we opted to not mandate the vaccine here at Albright, but we did strongly recommend vaccination. Obviously, we've had a lot of discussions about this, Adam, and obviously the 2 of us would be very happy if everyone was vaccinated, and this pandemic would, you would think, come to just a screeching halt if we got to that, which is interesting. Some of the other countries around the world that have really been successful at vaccinating large numbers of their population, some very quickly. now I'm talking about it, I forget which country
I
it
think
was.
Israel was one of the ones that was very good
Yeah,
initially.
yeah, they got up to 90% very quickly. They are struggling with the Delta variant right now, but oh shoot. Now I wish I would have written that down for this. I didn't, I didn't think I wasn't planning on talking about it. But they did 90% of their population and within like a 2 week period. It was pretty
Mhm.
impressive. I think it was, now it was obviously wasn't a hugely populated country. And I think geographically, I think it was small too. I think it was in somewhere in Asia. But anyway, maybe next episode I'll have more information on it. But they did 90% of their population within a 2 week period. So and that just happened within the last couple of weeks. So it'll be interesting to see what happens there as far as transmission in that country. It's been interesting to watch what's happening in Israel for sure too.
Yeah, definitely. And I think, I mean, anytime you have a country that has, open borders, if you will, like people can come in, they can come out, so of course Israel, is not under kind of lockdown, they're visitors and things. So, you can sort of introduce new naive hosts that have not maybe had the vaccine yet or had the infection. And I think it's clear with Delta that we're getting these what people call breakthrough infections of even vaccinated people. And I just want to stress, though, for those of us that are, for those that are listening today, that that is not in any way, shape, or form a negative against the vaccine in my mind, because Pfizer, Moderna, they've been shown in some recent studies. So the vaccine effectiveness goes down slightly to around 88 to 90% after the second dose against the Delta. But that 88 to 90% is basically like having a COVID positive test or symptoms, right? It's still largely preventing, I would say close to 99% of cases from people having to go to the hospital, right? So, in my mind, I wish they wouldn't call it breakthrough, because in my mind, the whole point of the vaccine all along was not necessarily to prevent any infection, but to prevent like severe disease and a hospitalization, right? And on that metric, it's doing a really good job and still doing a really good job. The Delta is definitely kind of straining it a little bit, if you will. Like it's really a harsh and very stringent test against the vaccines, but they are largely holding up well, luckily. But yes, so in the original study of, say, Pfizer, they came out with this headline of 95% effective, but that, and that was again at preventing anybody from having a COVID positive test or any kind of symptoms, right? So now that number's down a little bit to like mid 80s to 90, depending on the study. But again, no matter what, whether it was back then or now, it's still preventing severe disease and hospitalization in the vast majority of people. So again, I don't like the term breakthrough, because I don't think that was really the metric that it should be measured up against, is coming back positive. People are still largely remaining asymptomatic or mildly symptomatic against Delta if they've been vaccinated. So
And you're always going to have a small percentage of people who opt to get vaccinated and the vaccine won't work for whether it's a problem with the vaccine, that the dose they got, which is, I guess probably very unlikely, but if there's a storage issue or mishandling or whatever, or if your body just didn't react to it,
yeah.
or maybe there's just a million things that can go on, but for us to have 6% of people not respond to a vaccine is unbelievable. I mean, I can't imagine. Could you, if we would have been 70%, everybody would have been very happy with this. And then and then these breakthrough cases would have been much more prevalent. But like you said, it's not really breakthrough. It's just you take the very, very small risk of getting a vaccine in hopes that you don't have that you don't get the disease or get a complication of a disease that's as severe or worse than the complication from the vaccine.
Yeah, and that's a good point. I mean, these vaccines do carry just the slightest bit of risk in certain people. I mean, there's been a few documented cases of like Guillain-Barré, of a little bit of myocarditis in some population, et cetera. There is some association, whether or not it's a proven link, in my mind remains to be determined, but that is still like, say, 1 in several million. It's still very rare, some of these side effects, versus the much higher risk of severe illness, ending up on a ventilator, or even having, I mean, forget the hospitalization issue. What about long COVID? I mean, I feel like nobody's really talking about long COVID. When my wife got it, she still has not resumed her full sense of smell, and it's been going on almost 8 months now.
Wow.
And so there's this really small risk of vaccine complication, but a very real risk if you get COVID. Sure, you might have mild symptoms, but you might not be able to smell for 6 months to a year or ever, or you might develop a little bit of fogginess, sort of in a cognitive sense, or a little bit of difficulty breathing. There's been some case reports of healthy athletes that have got COVID that now can't run more than a couple of blocks without getting winded. So it's not something to be taken lightly, right? I don't want to be paranoid or sort of induce a panic about it, but it is not something to be taken lightly. So but yeah, so I mean, there is no reason in my mind not to get a vaccine unless you have a medical exemption, and that's a conversation between someone and their physician. Everyone should be getting vaccinated in my mind, right? Within reason. So yeah, so okay, so Albright, so what, I forget if the compact's been released like officially yet, but so we're doing return to campus, and is there anything else that you can tell us about the sort of the procedure for the fall?
Yeah, so return to campus testing, and then surveillance testing. So students that aren't vaccinated will be included on a list that will be picked. It's truly not random testing, because we're trying to get a selection of students from different areas in particular. So it's not necessarily random, but it's a selection of students each week, to see if to try to pick up any asymptomatic spread if it's happening on campus, so we can stop anything before it comes.
Right.
Obviously, that's the big. It's the most scary part, I think, with this Delta variant. I don't know if you're going to go there right away, Adam, but this, the infectious rate, the R naught on this one, it's better than what they first said. I was first reading 8 or 9. Now they're saying what I'm seeing more is 6. So for each person that's infected, they would on average infect 6 others with this variant, whereas the other. Initially, the R naught was looking at, we were at 2 or 3, and then once we drop, you hope that you drop below 1 so you can eventually have it have the spread fade away. But this one is much more contagious.
Right, and just so people know, I mean, the only way to get it below 1 is through basically mitigation. It's vaccination and masking and distancing and all those other things together. It's the only way to bring it down below 1. Left to its own devices, it's just going to keep spreading and spreading. So I mean, Delta, so if you mentioned that, Josh, it's estimated to be, they use the word transmissibility, right? So you're kind of alluding to that with the R naught, like how likely are someone to give it to somebody else. And the original SARS-CoV-2 was pretty infectious, but like you said, it was probably 2 or less than 2. And then the Alpha variant from again, initially from Great Britain, it was probably somewhere closer to maybe 2 to 3, and now this seems to be even higher. So it seems to be, I've seen articles estimate maybe 60% more transmissible than even the Alpha variant, which was essentially last summer into the fall and winter. And there's so I guess I'll summarize based on what I've read. So I regularly scan journal articles and these things called preprints. So they're not peer reviewed, but they're going to be soon, and people submit them so people can read them. And just from the popular press, and there seems to be some sort of highlights of this Delta. Number one, it does seem that there's higher levels of virus in like the respiratory tract. I mean, when they take like that Q-tip and swab up and, do the nose and all that, there's this one article where they estimate it's about 1,000 times higher virus that's detectable in the airway. And so that is likely contributing to why people are more contagious. If there's more virus in your airway, I guess, it makes sense that there's more chance of spreading it with talking, sneezing, all those things. And there's also some evidence on, so, the virus itself has these like spike proteins sticking out of the surface, and those spike proteins are what is in the vaccines, by the way. But the spike proteins basically are on the surface of the virus particle, otherwise known as the virion, as people say in the field. And so that binds to the host cell, and so that spike protein helps that virus to get into the cell to start a infection, and then takes over the cell, becomes like a virus factory, and starts churning out new virus, and then that gets released. But a lot of these mutations that make it a variant to begin with, right? So in order to be a variant, it has to be variable, right? So these mutations to the viral RNA genome, a lot of them are concentrated in this spike, and it makes sense because our immune system is attacking the spike protein. The vaccines only have the spike protein in them, so it's sort of like fixating the immune response on the spike. And so essentially, we as through vaccination and infection, our immune systems are putting a selective pressure. It's literally like survival of the fittest in a way. It's sort of like evolution in real time that we're watching. And so the virus is largely trying to escape the immune pressure from primarily our antibodies. So these antibodies float around and they try to bind to the spike protein before it can bind to our cells. And what's interesting, there's some evidence that I've seen that some of these mutations in the Delta variant are concentrated in the receptor binding domain of the spike protein. So they're concentrated in that area that is interacting with the host cell receptor. And the idea is that it probably can bind with higher affinity. So it's like, sort of like, like binding strength. It's binding, it can bind more strongly. And the reason that's helping to evade the antibodies is so if it's binding more strongly to our cells, it's less of a chance of an antibody binding kind of first and then preventing that interaction. So stronger affinity for receptor can help evade a little bit and get around that antibody response. And then also too, in terms of viral load, there's some evidence that the Delta variant, because it binds to the receptor more strongly, it can probably infect more cells, because even cells that have just a little bit of the receptor, which is called ACE2, just a little bit of the receptor, there might be a higher chance of it binding to what little is there and then getting into the cell. And so it's probably broadening the number of cells that get infected. And then overall, that's leading to more virus being made, like overall in total. So you're getting more infectivity. And just one other, like sort of on the biology side, there is some evidence that some of these mutations make the spike protein better able to bind to the receptor and also be like in I'll try to leave it general, but it's in a more sort of infectious state. Like it's gonna bind to and infect cells more easily, in addition to binding more strongly. And so it's in this like fusion capable, or this like ready to go state that it's allowing to infect cells better and probably more cells in total. So there's sort of like a multifaceted thing going on. Yeah, so that's a little
Strange.
bit of the biology side. What's that, Josh?
It's strange that I was surprised to see, the discussions about how many, how there's more cells, being found on patients that are infected when the when the morbidity or mortality of the
Right.
strain isn't any greater.
Yeah, I was actually
Thankfully,
gonna go there next. That's a great lead in. So on the
yeah.
medical side, like things you're reading more on the clinical side. So what's going on there with Delta compared to say some of the other variants in terms of the clinical presentation and the clinical like outcomes, I guess.
Well, so the NIH does, has guidelines for treatments, and they have shifted their guidelines of treatments with the Delta strain. So they are recommending a different cocktail of monoclonal. It's still monoclonal antibodies, so
Mhm.
it's the same type of treatment that they're recommending, but that has been a shift because they've seen better outcomes. And now these are in hospitalized patients
Right.
with monoclonal antibodies. So there's a whole clinical guideline with categories of how patients are presenting, whether they're going to need to stay in the hospital, whether they have oxygen requirements, and how they should be treated, depending on, and also depending on the prevalence of variants in the population. So so that's what's out there as far as from the medical side.
And what
And you would
about
think that if you were carrying more, usually if you have a higher viral load, you're more likely to be having worse symptoms or more symptomatic disease. I mean,
exactly?
just in general. So it's very strange to me. I haven't. Have you seen it? I haven't seen anything to say that any of these mutations, um, or any theories as to why that is.
No, I have not seen anything. No, because you're right. I mean, you would think that increased viral load would correlate with more severe symptoms and presentation.
Just like you were saying, as
Yeah.
it infects more cells, I'm thinking, oh my gosh,
Yeah.
there it is. There's your headaches because it's infecting those cells, and your myalgias because
Yeah.
even your muscles are being infected, and your kidneys and your lungs, and so you would just think that that would follow suit, but it just doesn't seem to be. Which again, thankfully, I mean
Sure.
that's what did they say? Um, the CDC director said something about the fear of the next big mutation, because it's not really a question of if, it's a question of when and how bad is it going to be.
Right. The longer it circulates, the more chance of another variant for sure. There are parts of the world, especially the sort of developing world or the underdeveloped world, that if they don't have access to the vaccine, or if the population has never encountered the virus before, right? So it's basically like, people call those like immune naive populations. Um, they can't get the vaccine. They've never had really the virus spread a lot before. These variants get in there, and as you sort of mentioned, it can continue to mutate the more it spreads. And so that's why we need to get jabs in arms as many people as possible, so that we can prevent another variant from forming. Because the fear, of course, is that the more it circulates, now you have a variant that might escape even the vaccines, which would be really scary, honestly. Because again, the vaccines have put, and I get why, it's easier, more convenient, and there are other factors. But I joke that these, our vaccine effort, we've put all of our eggs in the spike basket. Like, the vaccines only have spike instead, whereas somebody that has been exposed to the actual virus has a much more general and broader immune response, also including a lot of T cells as well. So you have these antibodies and T cells, and they can fight the virus from multiple angles. Luckily, the vaccine, even though it just has spike, it does generate a T cell response. And honestly, Josh, I think that's the major reason why these vaccines still work. If they generated just antibodies, I think we would be in more trouble. But they also generate T cells, and the T cells can kind of attack the virus at parts that are not as
Specific.
variable and aren't changing as much. So the antibodies are putting pressure to create the variants largely. I'm kind of overgeneralizing, but in general, a lot of these mutations are thought to happen because of antibody pressure, but the T cells are still doing a good job. And so I think because the vaccines do elicit T cells, I think that's sort of an underappreciated part of this whole discussion that most popular press and other people aren't really talking about. They just look at the antibodies because they're easier to measure. Honestly, they're just easier to measure and detect from, say, somebody's like blood sample, and you just throw them in a tube basically with virus, and you see how well they bind. And for the Delta, the antibodies do bind less well. They still bind, luckily, but they bind less well. But the T cells, I think, are playing a big role here. So luckily, the vaccine, even though it just has the spike protein in it, it does induce both antibodies and T cells. So I think that's an underappreciated part of this.
Do you think it's going to be a shift in your field, Adam, as far as virology goes? I mean, I feel like, we talked about this early on. I made that comment before about how difficult it is to measure that, but now it's happening. Now these things are being reported. Like you said, this stuff was never reported before in medical literature about, you had antibodies and you had antibodies. That was it. And we recognized that there was T cell and natural immunity, and there was a whole nother pathway. But it was just nice to talk about what we knew and what we could look at.
And you can measure like a titer. I mean, you could go to the lab and they could give you a titer. If you're a doctor, you can get a titer, even how many antibodies, right?
Yep.
And get an actual number spit out at you. I don't think the T cell things is going to change too much, unfortunately, because there is no like brand new technology that's been developed that makes it easier. The word that a lot of people use is high throughput, meaning you can measure a lot of samples in a very short period of time, almost like in a robotic sense. And I just don't think that's ever going to happen, or at least using current technologies with T cells. Just the way that they get activated and the way that you measure them currently, it's not very high throughput yet. And so I think it's gonna remain kind of small scale studies that we see, but not in a large scale sense. And it's also harder to talk about, like the way T cells work. A lot of people don't even know that term really, but almost everybody knows about an antibody. I think the only reason somebody might know about T cells is probably from the HIV pandemic and epidemic from the 80s, and until now, talk about, CD4 T cell counts and stuff like that. I think that's how a lot of people even know about T cells at all, but I could be wrong.
Yeah, the immunodeficiencies are some of them are very common, but then the more specific ones are much more difficult to diagnose, because you have to go through that whole process of elimination. You go after like you said, the easier ones first to knock off. And if a patient has a functioning immune system on that side, then you have to start looking for the more the rare types and more difficult to diagnose types of immunodeficiencies if you're concerned that the patient doesn't have a robust immune system.
Sure. And as a pediatrician, I was trying to learn this for immunology a couple years ago. I think there's some sort of I'm trying to think of the right word. Aren't there certain infections that if you see them become more prevalent, more common, that most people control just fine? Like if they have a bunch of ear infections, or they present with a whole bunch of wounds that won't heal right, or something like that. There's certain like warning signs, right?
Yeah, even meningitis. There's a long chain. Oh, you're making me go back on this one. But no, there's a terminal chain. I'm sorry, terminal chain deficiency that if a patient is sick enough to get meningitis, you have to wonder if their immune system isn't working right. So that's one of those things where you have to go for the very specific study looking at that part of the immune system to see if it's working. But I did see some of the vaccine candidates that are out there are looking at some of the other targets on the virus.
Yeah, so they are, luckily. Yeah, just not the ones that are currently licensed or authorized, right?
Yeah, didn't you think something would be out by now? I'm kind of disappointed. I thought the next one would be here in the United States. I mean, there's some emergency use in other
Yeah.
countries and approvals elsewhere.
Yeah, we're kind of stuck at three, right? It's Pfizer, Moderna, and the Johnson and Johnson.
Janssen, yeah, collaboration.
Yeah, collaboration Janssen. The AstraZeneca was being used in Europe some. I know there were some complications and issues with rollout and production, and there's even, I think, like a side effect issue. I have not been tracking that one as well because it's not in this country. But yeah, it would be nice to have, maybe like in a year there's some kind of booster of some kind. It would be nice if they could throw in one additional antigen to that, because there are other viral proteins. There are actually, I think, if I'm not mistaken, about 20 or so other viral proteins, and the antibodies are concentrated on the spike, but there are other proteins that would be more like a T cell target. And so I think it'd be nice to put in an antigen that would be more of a T cell target. So you've got this nice antibody response to spike, and then you've got a really robust T cell response to other to spike and an additional protein. I think that would be helpful. It's very reminiscent, and I talk about this in my microbiology and virology classes. It's reminiscent of drug therapy against HIV. I mean, back in the very late 80s, early 90s, as the drugs were just coming on the market, like the famous one, AZT, the first one on the market, it worked really well, and it really suppressed viral load in a lot of people, but they found that it only suppressed or blunted the viral load for a couple of weeks if you were lucky. And then it would just come right back again, right to where it was before. And now we know, because the virus mutates, because HIV mutates so rapidly, even more quickly than SARS-CoV-2, that now I think the standard of care, I believe is 3 drugs at once. It's called triple therapy or HART. And so you're basically hitting the virus from 3 different angles all at the same time. And it's sort of mathematically impossible for one virus to be mutated against all of those drugs all at the same time. And so now that's the standard of care for HIV. So it's, in the terms of the vaccine effort, I kind of think about that in the back of my mind. I've been very concerned this whole time about putting all of our eggs in this spike basket. So, but the vaccines are holding up, luckily. They really are. So I'll knock on what I can find in my office here. So yeah, and in terms of the Delta, you were mentioning about, clinical presentation. I know I've read that it presents a little differently, right? There's not a lot of people losing their sense of taste and smell as much. It seems to be presenting a little bit differently. Have you seen that or read about that? I don't know all the details.
Well, I haven't seen it yet, as far as I know, but the patients we've had in Pennsylvania, we assume that Delta's been here for a while, but we haven't had students on campus, so that's been a good thing. But there is some debate, whether or not it's the shift in age groups that we're seeing with more younger people being infected now. And is that why, or is it more specific to the variant itself, as far as why we're seeing a slight shift in symptoms? I mean, from a practical standpoint, it's, it can cause so many symptoms. If a patient has symptoms, they need to be tested, and then you go from there. So it's, from a practical standpoint, it doesn't mean a whole lot, but it does make you wonder exactly, where that's coming from.
Right. And luckily, with the advance and the ability to do the rapid testing, like at Albright's campus, for example, we can, if somebody presents, you can very, very quickly know within maybe 15 minutes or so whether or not they're infectious that day.
And I mean, that's another stroke of luck with this variant, is that our testing is still working.
Yes.
So yes, that's another.
Yeah. Luckily, the mutations have not been such that they prevent the test from working, which is good. Yeah, Josh, I just did a quick Google search here, and there's some from the CDC. So people are, again, this is not rigorously reviewed yet because some of this is so new, but the original SARS infection was associated in a lot of people with loss of taste and smell, but that's not being seen as much with Delta. So according to this article, the predominant symptoms and signs are headache, sore throat, runny nose, and fever. So
I was going to say fever. I thought fever and chills were a little more common with this. And then
yeah, it is a little more
headache
common.
was a big one that was early on with the original strain. A lot of people experienced headache, but so here we are back with it again.
Yeah, headache and sore throat and runny nose.
Some interesting theories on well, not theories. There's some interesting findings. They've found some on autopsies. They found some changes in the vasculature in the brain, and there's some things that seem to be happening from the infection that that they're seeing in at least in autopsy cases, and they think that may explain some of the brain fog that people have, and then obviously that would give severe headache too if you're basically having almost a sludging effect in the circulation of the brain. Is
yeah, a lot of people have complained about that fogginess. Yeah, and it can persist for a while.
Then of course the severe stuff, like you were talking about some of the side effects from the vaccines, but the venous thrombosis. And
right, like
the stroke issues that are happening happen with COVID. I mean, that was the thing they started to report that as the side effect of the vaccine, and then they forgot to say, this happens when you get COVID too.
Actually, in a decent amount too. I think, yeah, the clotting issues are somewhat common. It's not as rare as people think to have a clotting issue after COVID.
Right. Yeah, it reminds you of some of the stuff that with I mean, measles vaccine is one that I've talked with parents a lot about because there's parents have concerns, but the risk of encephalopathy from measles is significant. Now there is a risk of encephalopathy after the vaccine, but it's so much less. It's so much such a smaller percentage. And not that it's negligible, because it does happen, but that's that tiny risk you take. You take that tiny risk getting the vaccine, so you don't have the bigger risk of catching the disease and having the exact same thing happen to you. And so we're seeing that with these COVID vaccines too.
Yeah, and it goes back to in some of these people, and I mean we're getting glimpses now because we're 18, 19 months into the pandemic. But we still don't know exactly how the immune system is causing a lot of this. But just to remind everybody, the virus itself is not directly causing a lot of these complications and signs and symptoms and things. It's the person's immune response. So all that inflammation that, if not tightly regulated, can cause problems like the clotting and some of these other defects. So the immune system is a very interesting part of our body. It protects us and allows us to survive, because without it, even walking outside in a forest, or we're just inundated with millions of spores and bacteria and viruses, and we literally would not survive for a day without an immune system. But when it's not regulated and goes, it's too exuberant and too excited for too long and too much inflammation, it can cause problems also. And so I'm actually really anxious to see when they analyze the data, if there's a higher incidence of autoimmune diseases coming out of this, because there is, and again, this is an association, but I've read in some of my reading for immunology class that in certain individuals, they'll be like, I don't know, say 12 years old, and they'll get this like really severe, like, I don't know, viral or bacterial infection of some kind. And then 6 months later, they develop type 1 diabetes and have this brand new autoimmune disorder they've never had their entire life. And there's this interest in trying to figure out what is that trigger, right? And so I'm really curious if, people that have all this inflammation because of COVID, is that going to trigger a increase in the number of autoimmune disorders that are being reported like after the pandemic is over? And I don't know, I haven't seen anything yet, but I'm very curious about that. So, in fact, that actually happened to one of my students. She took immunology, and then when the class was over, she's like, by the way, like, I had, I forget what it was. It might have been like a severe ear infection, or she had like, I don't know if it was pneumonia or some sort of bacterial infection. And then about 3 or 4 months later, she said she developed type 1 diabetes. And it's hard to know cause versus correlation, right? Because just because one thing happened doesn't mean the next is related to it. But it is kind of suspicious. So when you see these little anecdotes piling up, you start to wonder if there's something there, but only time will tell. But yeah, I mean, like sort of oddly enough, Delta, it does seem to be increasing hospitalizations, at least in pockets of unvaccinated people, but they don't seem to be, luckily, like dying. And I guess maybe we're doing a better job of treating it. We kind of know a little bit better in the hospitals and these other clinical settings, like maybe how to treat it, or maybe they come in with some steroids to help dampen the inflammation, or maybe they use the monoclonals. I don't know, but the death rate has not increased. So just an interesting observation.
Yeah, we've been lucky with that. And when you look at with MERS being as deadly as it is, we know that coronavirus can do that, can have a mortality of 30%. And it's just it's very scary when we think about it that way, that we might just be a few jumps away from this turning into something completely different.
Yeah. And again, it's not meant to make people like fearful, but we just need to be more aware and more cautious and more, I think, like proactive, like get the vaccine, for example.
And it's funny that some things seem to move so fast with COVID and some things are moving slowly. When I knew we were going to do this, I was thinking about one of our conversations about the challenge study in the UK.
Sure.
And so I looked it up, and here they've expanded it, they've extended it and expanded it. So they're still looking for volunteers. There's actually an advertisement for volunteers for the COVID challenge study in the UK. But there's one that I had hoped we would have had those answers months ago, to give us an idea of what kind of level of immunity are we looking for, to be able to know that we're safe from COVID. There's one that went really slow, whereas these vaccine studies are moving very fast. A lot of them, some have been put on hold. I did some interesting reading on some of that. Some of the some of these vaccines ran into problems because of the surge of Delta. So some were put on hold because of that, because they thought that their data was going to be skewed on it. Some that didn't seem to be as effective as what they had hoped. So they were making some modifications. Others, totally different reasons. There's a company in California that did their phase 1 study, and then the company was sold, and all kinds of financial things jumped into the equation, and it's kind of it's sad when that stuff gets in the way, but we've been fortunate enough at least we have our 3 options that we have now.
Right. And again, they're still been shown to be very good. So, but that's, as of this recording, as people are aware, the CDC recently said that in areas of substantial transmission, that even vaccinated people should be wearing a mask indoors. And I saw some of the data behind that decision, and it came from I think they analyzed an outbreak, I think it was in Massachusetts, and in a few of the vaccinated people that were infected with Delta, the viral load in the vaccinated person was just as high as in unvaccinated people. And so that's what largely led to that recommendation. Now, we still don't know if that's the general rule for this, or if that's an outlier, right? Maybe that's not reflective of all vaccinated people, but it's sort of, out of caution. And we also still don't know, and this is, goes to what you were saying, Josh, about we wish we knew more at this point, right? Because there's all this attention and research, but the other thing we don't know still is if vaccinated people are able to transmit? Probably in some cases, yes, but we don't know how common that is, right? I would think that probably if a vaccinated person were to be contagious, I suspect that the window of transmissibility is probably shorter, I would guess. But again, there's really no evidence to suggest that. But the likelihood of a vaccinated person transmitting is probably low, and but we just don't know for sure. So here we are.
And it looks like people with Delta are getting sick a little bit faster too, and that's actually a good thing for control, because
In a way, you're right. Yeah.
then you can identify those people earlier, so they're not spreading it as much. And that's one of the things. I think in that same study they talked about how there was no secondary infections, but as soon as they identified them, they isolated them.
Mm-hmm.
So it wasn't like they let them run around and continue to spread it. So so definitely, I think that, like you mentioned, the things we're doing work. Social distancing, masking, the mitigation measures, and obviously the vaccines work very well. It's just a matter of us putting it all together at the right places at the right times, I think.
And unfortunately, I mean, this is not meant to be a political statement, but there are certain areas of even this state, but areas of the country that just are not buying into any of this. They a lot of vaccine hesitancy, and for many reasons that we don't have time to get into, but people just aren't getting it. And some of those people, I've just heard anecdotally, they don't really think it's a big deal at all.
Well, even you just mentioned that that report that that vaccinated people with high viral load. I just had that someone telling me that exact statistic, saying that that's the reason why you don't get vaccinated, which is exactly not the message.
No, that's true. But people aren't dying or going to the hospital. It prevents you from severe illness. And as someone, by the way, who has had COVID back in January, I would, and by the way, my case was still considered mild, if you will. I felt like crap. I would never want that. I would never say that it's no big deal. In my case, was considered mild. I mean, luckily got my sense of taste and smell back, but I lost that for a little while. But the worst part of it is for 7 straight days, I felt like I couldn't get out of bed. I felt like crap, chills and, muscle aches, and just, luckily not a high fever, low grade fever, but the chills and the muscle ache. I mean, to be simultaneously sweating because I have 8 blankets on me, yet also cold for 7 straight days. I mean, it's not like the flu. It is more serious. Like, we need to be taking this more seriously.
And a lot of the doctors in some of those southern states that you were alluding to with low vaccination rates are saying that their patients in hospital beds or in the ICU are saying, well, I changed my mind. I want the vaccine now. And they have to tell them that it's too late. It's not.
Yeah.
It's unfortunately not going to help them.
And right, like 99% of people right now in hospital beds from COVID are all unvaccinated. Just want to stress unvaccinated.
Unvaccinated, yeah.
So yeah. Sure. So some people may say, what's the point? Well, it's doing a good job, and it's very safe. Like I say, why not? Why not? There's so little risk to the vaccine relative to what could happen with COVID, right? Why take that risk?
Right.
I don't understand. I mean, I really, really don't. It's become so hyper politicized, and at this point, there's no turning back. So.
Yeah, I think I think early on, I think it may be more the news cycle. Everything is automatic now. It's immediate. You get the news right away. I mean, and so everybody's following it, second by second. So, we talked about this in the beginning when the vaccine came out. You get anxious about what's going to happen. Some of these initial studies, as phase 1 studies, are very small. We got very excited about the phase 1 studies, and then the phase 2, where they had hundreds of patients instead of just dozens. They still look good. And then some of these were phase 2, 3 studies, so they were combined, so they had thousands of patients instead. But then still you need millions. But now here we are, billions of vaccines going out. So yeah, we have. I'm okay with. I was okay with people being vaccine hesitant, especially medical people.
Sure.
Be vaccine hesitant early on, but now there's not a good reason for that. Now,
the safety data, you're not going to really get any vaccine with better safety data, in my opinion. I mean, it really doesn't get any better than this.
No, and then here's the next thing, Adam, which when this is all over, then all these we have an infrastructure to spit out vaccines left and right, and we're going to be able to target.
Yep,
I hope
plug and play,
strep throat, and cytomegalovirus and mono and all these things. Yeah, if you want, you don't have to suffer with any of these diseases. Maybe, and then I guess that's a question I have. For the future question will be, well, is there going to be something that, okay, you had the Pfizer COVID vaccine, you can't get the you can't get that nanoparticle in this vaccine because you'll have this side effect. That maybe, I don't know. Probably not.
Probably not. They'll test it. They will.
Yeah, they'll be looking at it for sure. And then it's going to be really hard. We already have a lot of vaccine hesitancy. We had a lot of vaccine hesitancy in the United States before COVID, and unfortunately, we're seeing it, I think, get a lot worse.
Yeah.
With COVID, and then I don't think it's going to get better as our toolbox expands with all the diseases that we can go after.
Yeah, I'm glad you brought that up. That is my number one fear from all of this, is that the vaccine hesitancy for COVID is going to ensnare many other vaccines, and there whether it's measles or mumps or whooping cough, you name it, right? Those are really well controlled but really dangerous infections, and I really hope there's not a resurgence in those diseases, because a whole bunch of people now are not going to get vaccinated. And all this.
It'll be. I survived the pandemic. We survived. Yeah. That's a thing that people like to say. I had chickenpox. Why do I need a vaccine? Why does my kid need a vaccine for that? Right. Or I never heard of hepatitis B. Why does my kid need a vaccine for that?
Yeah. Well, you haven't heard about it because of the vaccines, actually. And that's one of the problems. They're so damn good that we don't see these in our communities anymore. I mean, I was reading an article that, earlier in the 1900s, I mean, there were, of course, much larger families, but there are a lot of these communicable diseases all over the place, right? Whether it's smallpox or polio or you name it. I mean, if you had, say, 6 or 8 kids, chances were very good that one of those kids would not survive. Just they would not survive to adulthood. Or if they did, you'd have a couple of kids that were paralyzed from polio or couldn't breathe right from whooping cough, or you name it, right? And now that's largely not a problem, and people just aren't recognizing that if we're not vigilant and careful, that could come back. It really could. These diseases are still around, other than smallpox, which is declared eradicated, and polio, which is almost eradicated. These other viruses and bacteria, they're around in the world, and if we're not careful, they're going to come back. So
it'll be interesting if our mitigation efforts did anything with polio. I hadn't thought of that. It certainly had a major effect on RSV and flu in the United States and respiratory viruses across the world, but I wasn't
that's mainly polio. Masking, right?
Yeah.
Well, polio has made a bit of a comeback in certain parts of, I think, Asia and Africa, partially for, I think, because it's been harder for the medical folks to get vaccines in arms. right? There's too much disruption to the vaccine network because of other issues like the pandemic. So, yeah. All right. Well, again, I hate to end on a dire note, but I think, I think we kind of covered an overview of, why vaccination is important, and a little bit about the biology and things concerning Delta. So if, yeah, people have questions and would like a follow-up, be more than happy to do so. So just send questions to Josh or myself, and we'd be happy to, keep chatting, keep hopefully engaging and educating Albright. So Josh, thank you again for this, and it was good to see you here in the Zoom call.
Yeah, you too. Thank you. I really enjoyed it. I forget that we have that purpose of educating. I'm here having a good time. So sorry about that.
All right, take care, Josh. Thanks.